All right, welcome back. Today we're going to continue Chapter 10 with conics. Today we're going to focus on 10.2, which is circles. Our objectives today, first two not too bad. Write an equation of a circle given the center point and radius. That's something we've done before. Or find the center point and radius given the equation of a circle. The third one's going to be a little harder. That's finding the general form of an equation. We'll talk about where that derives from. And then we'll talk about how to do that, which generally involves completing the square, which we know how to do but haven't done for a while. All right, so equation of a circle, given a center point hk and a radius r, this is the equation of a circle. We take x minus h squared, y minus k squared, equal to the radius squared. So you're just plugging in the center point hk and radius r. For example, I got a center point at 7, negative 5, got a radius at 11. Just plug and chug. So x minus h is our h value, so x minus 7 squared. Y minus negative 5. So if you have a negative here, this will become a positive. And then our radius squared, 11 squared is 121. So given the center point radius, we can write our equation. Again, pretty straightforward from what we've done in the past. Flip side of that. Given an equation, now we're going to work backwards. You don't need a picture if that helps to draw the center point, and that's fine, but you don't really need that. From here, working backwards at the center point, again, it's going to be the opposite. So our x-coordinate is negative 3, y-coordinate positive 2. Take the square root of your radius here, so square root of 25 is 5. Again, these types of problems only take you a few seconds each to do. Another one very similar, once you read it, should help out. So we want an equation of the following circle. Center point at 6, 4. You can see I labeled that right there. Tangent to y equals negative 7. If you have a tangent of a circle, if you remember this from geometry, it touches the circle at one point. So this line, y equals negative 7, it's a horizontal line. We know it touches at y equals negative 7. So we're going to put this point right in line with our center point. So this point is really 6, negative 7. Because the x's are the same, it makes it very easy for us to find our radius. We can just look at the difference between 4 and negative 7 here, and we know that our radius is a length of 11. So really, this is a long way of saying center point at 6, 4, radius of 11. Once we have those things in, we can plug into our equation. So x minus 6 squared, y minus 4 squared, square radius, 121. All right, this is where it's going to get a little difficult here. General form of a circle. So we'll just start out with the equation itself. So this is the general form of an equation for a circle. X squared plus y squared plus dx plus ey plus f equals 0. D, E, and F will always be constants here. They could be positive, they can be negative, might even see decimals, generally not, but you might see that. But you won't see zeros for these numbers. What we'll typically be asked to do is we'll have an equation in this form, and we will have to work back to the standard form. We'll have to work back to x minus h squared plus y minus k squared equals r squared. That's what our burden of proof is the majority of the time, and we'll do that by completing the square. I'm going to show you a little background on this real quick, and then we'll proceed. If we take our standard form of equation of a circle, which is right here at the top, so you see h and k, you see our r squared. If we were to FOIL this out, so in other words, if I were to take x minus h times x minus h, I would get this first polynomial right here, these first three terms. If I do the same thing with y minus k and FOIL that out, I would get these next three terms. And hopefully you see I just took the radius and moved it over to the other side, so that's why it's minus r squared. Only to get it equal to 0, because that's what this form is. It's equal to 0. All right, so now I got a hodgepodge of stuff going on here. So I'm going to put x squared and y squared first, only because that's how it is in general form. Put my x term, then I put my y term. You can see I got h and k squared and r squared at the end. And this right here, this is actually our general form. And so hopefully what you see from this slide is that this D value is really negative 2h. The E value is negative 2k, and our F value is the square of hk plus k squared. So all I did was take the general form, or standard form, excuse me, FOIL that out, move the terms around a little bit, but D is negative 2h, E is negative 2k, and F is h squared plus k squared. So if we ever had to write this starting from the standard form of a circle, we just have to do these calculations here and it'll be okay. That's generally not what they're going to ask us to do. They're generally going to start in this form and have us work back to standard form. So we'll see that on the next slide. So I'm going to put a slide up here just for a second to help us out. All right, so here we start. You can see this is in general form, and we want to get back to standard form. All of these are even numbers, so I'm going to divide by 2. So dividing by 2 gets me here, and now you can kind of see this right here. We're going to complete the square. So I'm going to have to group my x's and group my y's, and this is really our square value. We're going to end up punting that over to the other side. So that's my first step here. So I grouped x squared and negative 2x, grouped y squared and 6y, and I took this constant and punted it over to the other side. All right, to complete the square, you may or may not remember this. It's been a while, so we'll talk through it. You take half of the middle coefficient and square it. So half of negative 2 is negative 1. If you square that, you get plus 1. Half of 6 is 3. 3 squared is 9. So I add 1 here, add 9 here. If I add a number or numbers to the left side, I got to do the same thing to the right side. And so you can see I added 1 and 9 to both the left and right side. Now these are perfect squares. So this is really x minus 1 squared. This second one is y plus 3 squared equal to 19. And that's what we want. We want to get from this form back to our standard form of an equation. Now we can identify the center point and the radius from here. So you can see our center point is 1, negative 3. Our radius is going to be the square root of 19. You can write it like that, or if you prefer the decimal, go ahead and write 4.36. But square root of 19 would work just as well. I'm going to go ahead and go through a second example of one of these. Again, we're going to start in general form and work backwards to standard form. Okay, let me throw a slide in there just to help out. All right. So again, I picked one here. Usually, whatever you see for the coefficients on x squared, y squared, that's what you're going to divide by. So this one's all even again. But if you saw 3x squared, 3y squared, then divide everything by 3. Or if it was 5x squared, 5y squared, divide everything by 5. So typically with these circle problems, we're going to cook that up ahead of time. So they divide out evenly. And you're going to see whatever the coefficient is on x squared, y squared, that's what you divide by. So we're going to divide by 2, and that's going to get me here. Again, I'm going to group the x terms and the y terms, and I'm going to move the 17, the constant, over to the other side. So there's my starting point here. So you see x squared minus 10x. You see y squared plus 4y. Move the 17 over. Now, I kind of did 2 steps in one. So I did that, but then I also completed the square right away. So how did I get 25 and 4? Half of negative 10 is negative 5. Negative 5 squared is positive 25. Half of 4 is 2. 2 squared is 4. So again, since I added these two numbers to the left side, I got to add them to the right side. If we did this right, we should always get a positive number over here because we can't have a negative radius. And we indeed do get a positive. So x minus 5, again, half of this was negative 5, so x minus 5 squared. Half of this was 2, so y plus 2 squared equal to 12. Again, that allows me to get my center point and radius. So my center is 5, negative 2. Radius is square root of 12, which has a decimal 3.46. And so that is going to be what we're doing with circles today. So you're going to identify the center point radius. or you're going to have the center point and radius have to write the equation. And then the third thing is going from general form back to standard form like so. All right, thanks a lot.